So we're going to talk about industrial control systems, cybersecurity in the digital age. For most of you who've been with industrial cybersecurity for a long time, this is new for us. Digital industrial control systems, and they've been around for a while, but we haven't really brought many of them in large scale across our entire operation. So let's talk about some ways to do this successfully. Of course, you always have to have a slide about the bad guys. Got to have a slide about your adversaries. I'm going to say it's very simple. This conference is about defense. From an adversary perspective, they have three things you don't. They have people, they have money, and they have time. Does anybody have all three of those things? No one does. Your adversaries do. They have almost inexhaustible amounts of money and time, and they will just eventually get enough people. So in this case, you're effectively, you're outmatched. You cannot stop this from happening. If they want in bad enough, they will take as long as it takes and spend as much money as they have, and as many people as they can put at it, and they will eventually get in. Somebody will make a mistake. Defense is very, very hard. You have to be right every day, all the time. Your adversaries have to be right once. You may be protecting 1,000 doors. They have to get in one. So the digital approach is honestly fairly new for us. I've been around a lot of control systems in my life since, frankly, the 1980s. And I've seen everything from pneumatic control systems to, obviously, the modern digital systems, where everything, front to back, is completely digital. We often call industrial control systems operational technologies, or OT. And it's different than IT. It's not information technology. And we like to say these things are very different, and what works in IT does not work in OT, right? These are different worlds. Not anymore. It's just T. Today, when you buy technology, you can't buy an analog piece of equipment. Everything you buy today will be digital. Everything you buy tomorrow will be digital. There is no more analog equipment being made. Your vendors don't sell it. You might find it on eBay or some second-hand market, in some engineer's garage somewhere, but you will not find it from your vendors. Everything you buy will be digital. So you'll have this span of technologies that you're working with in your company, where it's the old analog equipment and the brand new digital equipment. Why are we doing this? Why are we making everything digital? Because money. It's cheaper. It actually works better. It's easier to attack. But in every case, I've heard things like, we have an air gap. Our system is isolated. You do not have an air gap. You have a firewall. That's not an air gap. That's a network connection that allows data to pass through it. Maybe in one direction, if your rules are good. But it's still a data connection. The reason for this is, as we put more digital technologies into our environments, every single one of those digital endpoints creates a data stream. That data stream comes back into the business. The business does everything from look at operational efficiencies. Can we make the process more efficient? Can we make this better, faster? They're also taking that data and turning it into money. If Google and Facebook can make billions of dollars off of my dinner was fantastic, it's just frankly stupid data. How much is this data worth? It's worth an enormous amount of money. So the more data they create from these digital systems, the more money they make. And it's not just about determining things like mean time between failures for your systems, because we have very expensive equipment. This digital information helps this equipment last longer. We get more lifespan out of it. That's only part of the money. At some point in the not too distant future, our landscape will shift, and we will see a time when, whether it's water in a pipe, electrons on the wire, product being made in a manufacturing facility, oil being pumped out of the ground, whatever it is, the data about that process will be worth more than the product you're making. That is not too far out. There will be a time when your threat landscape will shift from not only protecting your industrial control systems, because they're making your product, or they're generating electricity, they're moving water, they're making oil. You have to protect that and all the data that's created about that system, because ultimately the data will be worth more than the actual industrial control system process. This is not too far out. So effectively, data is your business. Without it, you'll stop. I know very few organizations that can operate manually, like really with your hands, not behind keyboards, not behind consoles, not behind an HMI, human-machine interface. Very few organizations can do this. I think the Norsk Hydro ransomware event recently is probably the best example of an organization that they did okay. They got by. Still required a lot of effort, and they lost a lot of money in the process. Could you advance the slide, please? There we go. Whoa, too far. Can you go back? There we go. Perfect. Okay. So I've done this for a long time. I've seen a lot of different environments, electric, water, gas, mining, oil and gas, manufacturing, food manufacturing, agriculture. So lots of different industrial control systems environments. There's always the question of what works in ICS, what works in OT. Why is the security there different than it is for a web server or a database or an email server? It's different in that it's not the same. Basically, if you think about security, they typically use the triad, as they call it, of confidentiality, integrity, and availability. Of course, in the industrial space, we could care about nothing else but availability. It's got to be up. We're kind of concerned about the integrity of that information for now. Confidentiality, most organizations don't care. So it's really about availability. So what I've done is I've compiled a list of things that we know, that we've seen in the real world that have worked. There is some scientific basis behind this through some efforts called Visible Ops, in concert with various products from basically CERTs, or computer emergency response teams from around the world. First things first, identify what you have. If you don't know what you have, you can't protect it. There's going to be something important that you don't know somewhere, because we've all built our industrial environments over time. Very few of them were just built yesterday. They've grown over time, and many things have been added. And I can't tell you how many times I've walked through a facility and someone says, "What's that?" And the person who should know what that is doesn't know. This happens almost every single time I go through an industrial facility in a walkthrough. Almost every time. If you don't know what you have, you don't know what to protect. First things first, identify everything that you have. You need to know all of those things. From those things, what do you absolutely need to have to operate? Not what's important, what's nice to have, and that's going to be it's a difficult discussion, because everybody thinks that my things are critical. The stuff that I work on is critical to the operation. Maybe so, maybe not. So this is a healthy but a difficult discussion to have. What is actually critical for your operation to work? And then, of course, once you know what's critical, start there. Protect that first. That is the most important thing. That's the most important area to protect in your entire operation. Email can go down, internet connections can go down, everything else can go down, but this must stay running. Protect that first. There are some operations that can run 1,000 systems for one administrator. That's hard. That's a very mature organization. They've spent a lot of time getting to that place. Most organizations have so many unique systems that there are, in some cases, one person per system. Because the system is so unique, only one person knows how to operate it. That's not very efficient. And it doesn't work well in an environment where you need to react quickly in the event that something bad happens. If there's one, maybe two people that know that system, and that system is critical to your operation, you've got a very severe dependency on those one or two people. You don't want that. Uniqueness is bad. Individual systems are very hard to maintain because they're so unique. So one of the goals you should look for is immediately to figure out how many of these unique systems you have, why do you have them, and do you really need to have it that way? Can you change it so that there are more systems that are alike? This does create a different risk called common mode failure, and for the engineers in the room, you know what that means. But nonetheless, from a reactive capability, an incident response capability, a disaster recovery capability, this is by far your most efficient and effective approach. Not to mention it reduces cost. Most of us have inherited the environments that we're protecting. You're brought on, they say, okay, here's all the things, go protect it. Figure it out. Turn that around. Actually design the network so that you can defend it, versus trying to figure out how to defend a network that already exists. It is far worth your time and your money to redesign your network to one that you can actually defend. If you look back, the physical example is always fortresses or castles, right? There's usually a big, long plane out in front so you can see the enemy approaching, and then if they actually get through the moat, right, the water surrounding the castle, or they got to get through a drawbridge. They got one point they can come through. When they come through, in some cases, they're specifically turned a direction that the channel will turn them a direction to expose the side with the weapon so that you can disarm them as they come through. It's specifically designed so that it can be defended. Intentionally designed that way. If your network is not designed that way, it's going to be very challenging for you to defend it. So consider the really important networks, those most critical things. As you isolate them in networks that were designed, purpose-built for defense. If you have industrial control systems on the internet, you are doing it wrong. You failed the test. These systems should never be on the internet. They were not designed to be on the internet. They're extremely easy to hack. Most industrial control systems were never designed with security in mind. They were designed to run a long time, never being rebooted, in extreme environmental conditions, and do one thing and one thing very well. That one thing has never been security. These systems need to be protected by many layers of defense. If they're on the internet, they're likely already hacked. You may not know it. It might not look like they're hacked, but they're probably still hacked. Your really good adversaries don't come in the front door with a marching band behind them. They come in quietly, and you'll never know they're there. Remote administration is okay. You can actually administer an industrial control system from somewhere else, but you have to do this securely. The recent attack on the Ukraine is a good example. They came in through the IT systems. They came in through the remote access environments. The attack could have been prevented, arguably, by multi-factor authentication at the perimeter. Something as simple as a token could have stopped a blackout. So you can administer the systems remotely. Do it the right way. Don't just allow anyone to have access, or even the trusted people, even allowing them access. You have to go through the standard approach. You have to use things like multi-factor authentication, one single point for access. Vendor support, we all know there's only so many vendors in our space. In the industrial control system space, there's only so many manufacturers. And the equipment that we're working with usually requires the vendor to access it, to monitor it, fix it, tweak it. That's okay. Just make sure the vendor is coming through the same path, because we've seen many situations where hacks have come through the vendor channel as well. So this is 2019. We're approaching 2020. And I hear from operators all the time, oh, we can't have individual accounts. We must have these shared accounts so that we can get in quickly. If we see an alarm, we have to respond quickly on the HMI to protect the system. I would argue that in almost all cases, not in all, but in almost all cases, that's wrong. You can have individual accounts. Individual accounts limits things like escalation of privilege, span of control. These are all standard fundamental security practices that are absolutely violated by one single administrative level shared account that 20 people know. And some of them may have retired or have been fired, and that single account and password has not been changed in 20 or 30 years. And in some cases, it's the same account that was given to you by the vendor when they manufactured the product and you never changed it. This is actually really common. I've been to big manufacturing facilities where administrative control over the entire control environment, username, ops, password, ops, OPS. If you can't remember that, and you have to write it down on a sticky note next to the console, again, you're doing it wrong. Most of these systems now are built on Windows. Some still use the Unix or Linux environments. They almost always have an Active Directory. Active Directory supports unique accounts very, very well. Some of the newer environments, you don't even have to log in. You just log over the existing person. Some of them you can use your proxy, your badge access to log in for quick access in case you need to interact with the system immediately. There's lots of new options. You actually can, today, without impact to your operations, run individual accounts. Patching. A lot of these organizations just don't patch, ever. They just don't patch. I've seen some environments that are Windows NT, and they have not been patched since the install. Those of you who know about this environment know just how easy this is to hack. You could fall down on the system and hack it. It's just as easy as possible. So why is this allowed? Because in most cases, you will break the process. These systems cannot go down. That's okay. You just have to protect it as though it is something that is that easy to hack. So understand the fact that if you do not patch, your threat level, your need to protect that environment goes up dramatically. Patching is the easiest way to solve the problem with most security issues. I think it was a release from, I believe it was Gartner, that showed like 98%, if not more, of all of the security incidents that have happened in the world would have been solved by patching. That leaves you with like 2% or less to protect. Makes your job a lot easier if you can just patch. In our world, we can't. So defense, you got to defend it accordingly. Defend it as though it has never been patched. We do have situations where vulnerabilities get disclosed in industrial control systems, and they will never be patched. The vendor says, we are not going to patch that. Or the vendor says, that's a feature. It's not a vulnerability. This happens. We call those forever days. You've heard of the term 0 day, the first day the vulnerability gets disclosed. Forever days are those vulnerabilities that are disclosed and they will never be patched. It's just part of the environment. So given the fact that we've got a patching problem, we can't patch in a lot of cases or won't patch. We have situations where our vendors do not patch. That takes the level of defense up much, much higher. You effectively have to defend the system as though it's never going to be patched. That's just an assumption you have to make. Now, part of this is tradition. In some cases, we don't patch because we're afraid to and it broke some system 10 years ago. It's actually gotten a lot better over 10 years. Patches don't break the environment nearly as much as they used to. In a lot of cases, we are using virtualized test environments, or a QAS, a quality assurance system in advance. In those situations, you have an ability to test the patch. I've seen new generation capabilities in the electric generation space. They will virtualize the entire plant. Everything, a digital twin of the entire plant. You can test a patch there to see what happens. So it's not impossible. Don't believe just because tradition has told you that you shall not patch or you cannot patch, that you can't or should not. Controlling change. Usually when something breaks, it's not because of the system. The system doesn't just decide to break. Yes, hardware failures happen. Hardware failures happen less in our world. They happen less in the industrial control systems world because our systems were built for that. They were built to actually operate through hardware failure. Or they've been environmentally hardened in such a way that the typical hardware failures of overheating, clock speed, these kind of things just don't affect our systems. They were designed with that in mind. It's almost always because somebody changed something. That is I would say, that is the most common reason for an outage of any industrial control system. Somebody changed something. A human being did something. If you can't control change to your environment, you will never have a secure environment. You will never know what happened. Now, from a defense perspective, if you don't know the changes that have happened to the system, when you go to defend that system or reconstruct that system from something like a wiper, right, that just bricks your systems, not knowing those changes makes your recovery time longer and much more challenging. Understanding every single change that happens in your environment is absolutely crucial to managing your environment over time. Changes aren't always bad, and I would say easily 80%, if not more, maybe even 90% of the outages that I've seen have been due to human accident, not because a threat actor actually did something bad. It's usually just humans making mistakes and not recording the changes. And sometimes they make the change, they don't want to tell anybody they made the change because it causes an outage, it just never goes resolved. This makes your root cause analysis much more difficult. All of these problems come from changing the system. Control that change as tightly as you possibly can. Nobody can log in, nobody can make changes without approvals. Once you get to this stage where you've identified your systems, you've figured out what you're going to do about patching, you know that you can actually use individual accounts, these standard, fundamental kind of crawl, walk, run stage. Now we're at a more mature level. So at this point, you want to monitor everything. You know what you're protecting, you know what your environment looks like, it's built to defend, you know the places, the actual access points that you want to look at. Now you want to monitor everything, especially the network, because these systems will be talking over a network. Yes, you can even monitor things like Profibus and CAN bus and LNG, and if God forbid you're running protocols like a Conatel 300 baud. Yes, you can even monitor those, believe it or not. We do have the capability to look at serial traffic and inspect that in addition to IP. So that can happen. Know what your system is doing. Not only is anomaly detection a great thing, and there's plenty of anomaly detection vendors out there, the initial selling point was this can test when it actually learns your environment, and it learns what looks normal. So something abnormal is probably going to be a malicious actor doing something to your system. Great. And these tools do what they say. They do exactly that. But what we found is what was sold to us as a security tool has far more value as an operational tool because we can actually see what's happening. You're like, I never knew those two systems talk to each other. Why do they do that? And you actually get the operational efficiencies far better than you do the security product benefit. Sure, use it for a security product, but in reality, you're going to get a lot more operational benefit from doing this as well. It makes your operation better. You actually know what's happening inside your environment. These products actually work. So I say, don't rush out and buy them. They're great, but honestly, if your organization is not mature enough to use that kind of intelligence, why buy it? Don't waste your money yet. Get through those initial steps. The example I always use is don't buy an alarm system if you're not locking your doors and windows. It doesn't make any sense. There's no need to alarm and detect on someone coming into a window that's unlocked. You didn't even lock it. Okay. Regulation. I am a recovering regulator. I was a regulator in the United States. I wrote the NERC SIP standards for the electric sector, and I actually audited the electric utilities and wrote million-dollar penalties if they decided to violate the regulations. I can tell you from experience, regulation is very hard. It's very easy to get regulation wrong. Regulation written quickly is often bad regulation. You need to think about it, let it grow organically. So my example is, regulation often makes people feel secure because there's a, you have to do these security things. So my regulation I'll make right now is if you ride your bike, you have to lock your bike to a provided bike rack. This bike is compliant. This bike is within the law. It's no longer a bike. It's useless. But it's compliant to the regulation. It meets the regulation. Compliance to a regulation and security are two different things. Hackers will move faster than laws every single time. Laws prescribe an action. Laws tell you what to do. Laws don't motivate you to want to do it. They're two different things. Writing regulation that motivates industrial organizations to be more secure at their own cost is very hard to do. So regulation is good, do it, but understand the value of what you're going to get. Frameworks. There's many, many, many frameworks. Pick one. Pick any one of them. They're all the same. They're different names. I'm Italian, it's like Italian food. We use the same ingredients, we just mix it up a different way and call it something else. Frameworks are the same thing. All the controls in all these frameworks, all the digital controls, all the human controls, they're all the same. They're just placed into different buckets with different names on top. The main thing is you need to pick one so you can measure where you are against others in the same framework. This is how you measure your success. This is how you follow a roadmap to make sure you're actually getting everything. Pick one. Just pick one and go forward with it. You don't have to be perfect at it. And you can change. Again, they map to each other. Ultimately, at the end of the day, it's up to every single one of you in this room to defend these systems. You are the weakest link in the chain, or you're the strongest link in the chain. All of that technology is there to support you. It will not stop the attackers. It will not rebuild the system. It will not defend against the attackers. That's your job. At the end of the day, after all of these technology things, all the blinky lights in data centers, they're there, but they're your tools. They don't do your job for you. This ultimately is on you. This is what you get to do. That's what we signed up for. That's why we do what we do. It's a good thing. There's only so many of us in the world, and we have to do our job very well. So, last thing, resilience. Everyone talks about security, and we should secure these systems. No, I argue that security is actually part of the problem, part of the solution. You have to actually keep your system running. That's different than keeping your system secure. The system must continue to run always, even if it gets attacked. And attacks are going to happen, and you cannot stop them. You cannot stop all of them. So you are there to be resilient. You're there to operate through the attack, not stop it from happening. Recover from it while it's happening at the same time. Those are different concepts than just preventing it. So when you think about security, think about it not just from a prevention standpoint of stopping the attack, but also operating through it and recovering in the event of one. So my question to you before I leave for the keynote speech is, what will you do? How will you defend differently tomorrow? You are not going to solve tomorrow's problems with yesterday's thinking. If you continue to do things the same way, you will likely fail. How are you going to do things differently? How are you going to defend differently? And that's my question for you. Thank you. Yeah.
Evet, EnergySec US Kurucu Başkanı Sayın Miller, değerli sunumlarınız için teşekkür ediyoruz. Kendisi aynı zamanda kariyerini EKS Siber Güvenliğine de adeta vakfetmiş ve bu alanın da duayen isimlerinden birisi. Bu özel toplantıda bizlerle olduğu için de ayrıca kendisine huzurlarınıza çok teşekkür ediyoruz.